Dear students, I have come with a new module, Introduction to Measures of Dispersion. So this is the next step. After computing the measures of central tendency, we have to compute the measures of variation. Now what is measure of variation? Sometimes we may get different series to compare. The average will be same, the mean value may be same, but there will be wide variation in the composition of the series. That is what we are going to explain with measures of deviation or measures of dispersion. Both these terms are used, measures of deviation and measures of dispersion. So if you explain this topic, averages gives one figure to represent the data, the mean, median or mode. One figure we will get a value, whereas averages alone cannot describe the data. It is necessary to describe the variability or dispersion. What is the difference in the composition of the series? I will give you an example where three sets of data I will give. The mean value is same, but it's different, totally different. The composition of that series is totally different in all the three cases. So in two or more distributions, average may be the same, but wide variations in the formation of the distribution. That is what I am going to explain with the example. So this is possible only by studying measures of variation or measures of dispersion. So the example I am going to give, three series of data I am giving. First one is all the values are same, 100. The total is 100 and the mean is also 100 because 500 divided by 5, the mean is 100. The next distribution is 100, 105, 102, 103, 90. Here also total is 500 and mean is 500 divided by 5, it's 100. The third series is first value is 1, next is 489, next is 2, next is 3, next is 5. Total is 500 and the mean is also 100. So here you have to remember we are comparing three sets of data. The mean is same in all the cases, but whether the series or the formation of the series is same, no, it is not same. So in series A, all the values are same, the variation is 0. There is no variation at all. Whereas for series B, variation is small compared to series C. Series C, there is wide variation in the composition of the data. So this is what we are going to do, or we are going to learn with the help of measures of variation. So the definition, Kafka defines measure of variation as the measurement of the scatterness of the mass of figures in a series about an average is called a measure of variation or dispersion. So from an average, and usually we are using mean as the average because I told you mean is based on each and every value in the series, mean computation. So from mean, how these values are different, how the formation of the series is different. That is what we are going to learn with measures of variation or dispersion. So measure of dispersion, in simple terms if you say, it's the spread or scatter of item of values from a measure of central tendency. And the measure of central tendency we use is always mean. So objectives of measuring variation. First point is to measure exactly the reliability of an average. How reliable is the average? Average rate or the average run scored by a batsman, average marks scored by a student, how reliable this data, how we can predict his performance or her performance based on the average or the already what we got the reliable data. So then to serve as a basis for control of variability, if you know that what is the dispersion, what is the variation, then we can do some techniques to control the variation. Next is to compare two or more series with regard to their variability. The performance of two students who are getting good marks, or the performance of two students who are getting average marks, or the performance of two companies, or the performance of two batsmen in a cricket match. All this we can do with the help of measures of variation. Next is to facilitate the use of other statistical measures. This computation we will use for further statistical computation. Next is properties of a good measure of variation. First one is it should be simple to understand. Everybody should be able to do that. Even a student without any mathematical knowledge, he or she should be able to do that. Next is it should be easy to compute. You learn the equation, substitute the values, you should be in a position to get the answer. Then it should be well defined. It should be well defined. There should not be affected by any sampling techniques or sampling variation. Then it should be based on each and every item of the distribution. It's very important. Statistical computation, if it has to be accurate, it should be based on all the values in each and every item of the distribution. Next is it should be capable of further mathematical treatment, algebraic treatment. We can use for further statistical treatment. Then it should have sampling stability. So it's very important. The value should not be affected by sampling fluctuations, and it should not be affected by extreme values. So that is also very important. If one value, the opening value or the closing value, is totally different from the other values, computation should not get affected. Then two things you have to remember: absolute measure of dispersion is there and relative measure of dispersion is there. So absolute measure of dispersion is expressed in the same unit. When we are always talking about comparison, those two sets of data will be there. So this absolute measure meaning it will be expressed in the same units. See, for example, production of rice. The first data is expressed as kilograms or tons. The second data is also expressed as kilograms or tons. The units are same. Then we can use the absolute measure of dispersion. Examples: range, interquartile range, mean deviation and standard deviation. If two sets of data are expressed in different units, relative measure of dispersion has to be used. See, for example, you are comparing the salary of a manager with the salary of a casual worker. There will be wide variation. Though the unit is same, it will be wide variation. Then we have to use the relative measure of dispersion. Examples: coefficient of mean deviation, coefficient of quartile deviation and coefficient of variation. Now, a measure of relative dispersion is the ratio of measure of absolute dispersion to an average. So, average, we are always, whenever we are saying average, we have to remember we are talking about the mean, because mean computation is based on each and every value in the observation. Then it's usually measured as an average of deviations around the central value. So, how this series is different from the mean value, that is what we are going to do with the calculation. Now, arithmetic mean is used in calculating mean deviation and standard deviation. And measures of dispersion is thus a type of average and also known as second order average, because from mean what is the deviation? So the second order average, that is why it's also called measure of dispersion is also called second order average, because from the mean we are computing the deviation. Now, relative measure of dispersion is also called as coefficient of dispersion, meaning coefficient means a pure number that is independent of the unit of measurement. See, always I used to tell you that you have to write the units when you are writing the final answer. Whereas coefficient or relative measure, you have to remember that you should not mention the units, because we are calculating without giving any importance for the units. Because two series, it may be expressed in different units, but we can compare that with the relative measure of dispersion. That is the advantage. Unit has no value in relative measure of dispersion. So for computing relative dispersion, the average used as a base should be the same. So whatever the average we are using, mean if you are using, mean should be the same. Mean only we can use for both the series. Now, what are the methods of studying variation? So 4 methods are there: range, quartile deviation, mean deviation and standard deviation. So this is what I want to explain with this module. Thank you.